Well, hello. Hope everyone is doing good today. In case you did not get the chance to see it, this recent Friday on September 24th, 2021, there was a DevilSec presentation of a bunch of different quick talks that went over various different topics. One of the topics, which I will be covering in this video, was my presentation on command and control. Unfortunately, I was not there to give the presentation, and this was because I had some other issues to do at work, and I unfortunately could not make it. So thankfully, Nightbane, also known as Matt, was able to take over and give the presentation for me, and so I'm very thankful for that. But I hope that based on his presentation, and you can also see that actually at twitch.tv/DevilSec, if you know, I would take a chance to watch that because that was a very good presentation that he gave of my slides. I think he actually worded a lot of things a lot better than probably I will in this video. But I kind of wanted to make this video to add to my, I'm going to be making a playlist about how command and control frameworks work. I'm going into a few different ones and then also trying to work out how to set up your own environment. And we might do some additional stuff along the way. I don't really have a curriculum exactly planned out yet, so we'll work on that. But like I said, I'm going to be giving the presentation here in this video. And yeah, without further ado, let's just move into the presentation. So the title of this was Command and Control Your Pen Test. This is the slides, or this is the presentation about command and control and you. So first off, this is who I am. If you want to reach out to me at all, I'm on Twitter, Discord, GitHub, Instagram. Just reach out to me at any of those platforms and I should be able to respond to you. So let's first start with some things you might know. These are things regarding how normally a computer would get compromised. If you were to talk to, say, some other system and be able to somehow get it to talk back to you and give you shell access to that system, what are some methods you might be able to do that? So one that is pretty common that you might see a lot for like scammers and such is usually command and control through phishing emails. They'll probably tend to send like not command and control, sorry. They'll send a malicious payload through phishing email, and then that phishing email attachment or link is going to send something out back to the attacker, therefore giving them access to that target system. Another way is program exploitation. This is not necessarily something that can be prevented, but through, say, like phishing email training. This is just, there's a systematic flaw in how this program is operating, such that if an attacker was to interact with it maliciously, it would be able to give them access to some sort of command line environment or be able to run arbitrary commands on that computer. So why, not why, but how are some of these actions taking place? So kind of explained it a little bit, but generally it's the attacker will send something off to the web server. This is if, let's say, we're doing like an exploitation, for example. Send something to the web server, which then will forward it to the app. The web app will then process it, and whatever the vulnerability or the bug that occurs will then become exploited and start executing the arbitrary code that the attacker wants to execute. That arbitrary code is going to spawn a bash shell, which then that bash shell is just going to be able to then reach back out to the attacker and start talking to them. So then this is how the attacker over here can be able to have access to a bash shell that's running on the web server. But generally, why is this bad? Because if I have a singular shell, why would it be bad that I can't, or that I have access to this? It shouldn't be bad because, I was able to successfully exploit the target system. I was successfully able to phish them. So this shouldn't be a problem. But in a lot of sense, it is, because it really comes down to scaling, I think, for a big part of this. Because having multiple connections where you have maybe 40 targets that you've infected, how do you juggle all of those at once? That's really difficult. And then on top of that, sometimes these shells are very unreliable. If I have a bash shell or a PowerShell instance or some non-standard shell, but it still is able to do arbitrary code execution, it may be that it works, but it just is very fickle. It could break. Something you could do, maybe like Control C, could easily just kill your shell, and that's not always a good thing to have. If you have something that could handle that, that would be super nice. And then another thing that's more of a quality of life is how can I share connections? If I have a bunch of connections that are between different people, say other operators, and I want to be able to share these already compromised systems with my fellow operators. How can I do that? Like, there's no straight way to do that other than maybe like sharing my computer, or if we share a server, it just doesn't really work well. Um, and so this really leads into these mitigations that I was speaking of, because some of the mitigations don't always necessarily mean that it's better, right? Like, we can mitigate the fact that we have multiple shells and mitigate it with having multiple terminal windows or panes, but that becomes strenuous because now we have to deal with multiple tabs, multiple windows, and figure out where stuff is, and it's a cluttered mess. We have a reliable shell that we might want to get. Well, we can have a little bit more reliable shell if the system might have like Python, for example, or maybe Ruby, because we can spawn a pseudo TTY or pseudo teletype interface, or typewriter, I think it is, teletypewriter or something. But basically, this will give us an interface which allows us to properly interact with the shell. And let's say it's a very minimal environment like a Docker container. You're probably not going to be able to have that luxury, unfortunately. You're going to have to deal with that really unreliable shell. If we're trying to share connections again, like, there's really no straight way to do this. It's pretty inconsistent, and the methods that you can do this require a lot of overhead. And if I want to run third-party programs, maybe say like WinPeas or WinEnum or LinPeas, there's not an easy way to just run it. Normally the process is I have to take this file, somehow transfer it to the remote system. And this might be through like wget, for example. Maybe you stand up a Python web server on your attacker machine, and then you say, all right, well, I'm going to have the target machine curl or wget or finger or do something to pull that file over. And sometimes, yeah, you should be more than able to. Other times, maybe those applications are either disabled or they don't exist on the system, and now you have to find more alternative ways to move it across. And for more locked down systems, it becomes harder and harder because sometimes it's really not as easy just to get files over to another system. Sometimes you do have to do the copy and paste idea where you just kind of copy paste the script into some file, but what if that file doesn't have a text editor, or that system doesn't have a text editor? So now you have to deal with actually trying to paste on the command line. And then you have to deal with the command line not handling things correctly because now you're copy pasting. And like, you see how this thing kind of bounces back then to the reliable shell, and it becomes just this gross amount of overhead that you'll have to deal with. And as an attacker, really, I want to be able to focus on something that's going to give me a better quality of life. So that kind of leads into this being able to streamline these techniques, these mitigations, and have just a generally good user experience. As a hacker, I don't want to have to focus on my shells dropping or dying. I want to be able to focus on, of course, whether my operational security is intact, or if I'm attacking something that's the correct target, or what my targets are even. I don't have to sit here and juggle 40 connections and have to remember what each one is because for some reason my tabs are too small so the names aren't made out, and it's a lot that happens, and it becomes more overhead than pretty much what the engagement might be worth at that point. Now, the answer to this, and you probably already know this considering that's what this presentation's about, is command and control frameworks. Really, it's, command and control could be as simple as a single netcat system, but most actual like command and control products and software are generally it's a framework or a grouping of software that allows for say an operator or a group of operators to orchestrate multiple connections with just this huge environment that allows for maybe different commands to be ran that aren't exactly shell commands, and something that's really easy to use for the user and to allow them to do these other non-trivial tasks more trivially. I would say other types of features, which is kind of what we were talking about before, was things like information management. Or we weren't talking about information management before, but we were talking about, implant commands. This is the thing I was saying, it fixes the fact that we don't need to use a shell. We don't have to use the bash shell. We don't have to use PowerShell. We don't have to use a really crappy Ruby shell. We can just use whatever the commands that run inside the command and control system, and then it just commands the implant or the program that we have injected onto that system to do those commands. Super simple, super sweet. And then standalone executables, again, that's kind of like that's a little implant that's on there. We don't have to depend on bash or PowerShell. This is all self-contained, not dependent on the environment, and just runs in the system, which is brilliant to have and to not have to depend on the environment that you're running in to be able to execute the code that you need. Sometimes it's nice, other times it's kind of a pain. Connection manager, those multiple connections, you got to say, once it gets to like 50, 60 connections, if you ever do get to that point, that's going to be pain. So now if I can have just like a nice listing that can handle multiple connections, that's really nice. And I can bounce between different sessions of exploited targets. Very nice. And then information management, that allows me to really log a lot of things. That allows me to not only log what systems were compromised, but also log maybe the hashes that I collected, the users that were on those systems, and maybe what commands I ran. And that helps for, as a pen tester, if I'm trying to write reports, I can include all of that information in my report and not have to try to conjure up what I did. Because sometimes you get in the heat of the moment and you just totally forget what you ran, which can be a pain to come back to. Some other additional features that you might be interested in are encryption. Encryption is one of those things that's, as a pen tester that's trying to be a professional business, I really don't want my customers' personally identifiable information or PII to get out there to the world. That would be a big no-no. I would actually could potentially get sued for that. Payload generation, I don't have to worry about making my own payloads, just kind of does it for me. The multiplayer support that we were talking about, we allow multiple people to be able to connect to the same server and share the wealth upon other exploited targets. That's really cool. Obfuscation is super slick because this allows us to generate payloads which may not get detected by normal antivirus or AV systems, or EDR, which are endpoint detect and response systems, which you might see on most systems, such as Windows systems, which, common ones like Windows Defender or Norton or McAfee or Avast, or if you're talking about EDR systems, I think Norton also has their own, so does McAfee. But things like, CloudStrike, it could bypass those because static analysis sometimes is just not all you need to analyze a binary. And if that's what that EDR or that AV is using, then you can bypass that pretty nicely. We have stage payloads. Sometimes it's really nice to be able to just split up a payload in a smaller and a larger chunk. So I'm not sending 500 or 600 bytes at once to a certain target. I can keep my payload small, so it's not as detectable at first, so that I can then get my little kind of foot in the door, slip anything I need into that door wedge, and then close the door, and then continue on with my day, because now I've gotten my shell into the target. And yeah, maybe it got detected, but now I have access to a system, and I can start doing some pulling apart later. Or just trying to make sure that maybe the other bigger part of my payload doesn't actually get burned, and now I just have a simple reader that's waiting for my connection to talk to it. Networking capabilities, I think, is probably the strongest part of a lot of C2 frameworks. This is one you'll use a lot if you're trying to pivot through a network. One main thing that you'll run into when you're, say, trying to initially compromise a network is, say you've compromised system A, but now system A has, it's part of its own network, right? Even though it reached out to you, it's still on its own network. It's not technically part of your network. So how can you communicate with that other network? Well, one of the ways you could is through just the native shell on the system. But again, we already talked like that's not always really reliable. So what if I could put Nmap on there? Well, you could potentially, maybe the binary or maybe the implant that I have allows me to do network scans, and that's pretty trivial. That's not too hard to do. But what if I wanted to do something a little bit more advanced that wasn't just native port scanning? Maybe I wanted to actually run like Nmap scripts. Well, that becomes a little bit less trivial. So one of the ways that you can get around that is when your C2 framework allows you to do reverse port forwarding, or even just SOCKS proxying, which then will allow you to proxy all of the traffic that you're sending through a tunnel that basically comes out like it's coming from the infected host. So I could send Nmap queries and scans and any other traffic really through that tunnel, and it comes out into that network of the target or the victim that's been infected, and I can query results against other hosts basically that are in the network like I was just attached into that network, but I'm really not. So that makes that very powerful to do. Some common C2 frameworks. We have Metasploit. We also have Cobalt Strike and Sliver. Metasploit, as you might know, is a free and open source exploitation framework that has really pioneered a lot of the innovations in command and control that are used professionally. Even some that are used non-professionally, because a lot of the concepts in this are very well built. It's developed by Rapid7, and it's really, like I said, it's pioneered a lot of the features that you might see even in Cobalt Strike or in Sliver or name your C2. Uh, Cobalt Strike though is not free. It's a it's a paid one. It's a paid version. It's a paid C2. It's mainly used by professionals in the field, people such as Trusted Sec or other types of pen testing companies, maybe like Bishop Fox, will make use of Cobalt Strike to generate payloads that are more advanced and really are set above the rest. Unfortunately, though, this really only works for Windows. I think they're coming out with a version later on that works for Linux, but that's in the works for now. Sliver is a Bishop Fox built command and control framework, and the really cool thing about this is it actually is cross-platform. So like Metasploit, it works for Linux, Windows, and Mac. However, the difference here is the obfuscation engine that runs in the background for Sliver. I forget again what the packages that it uses for the obfuscation. It used to use GoFuscate, but they changed it recently because of how long GoFuscate took to obfuscate certain payloads, and they made a better or a more efficient obfuscation engine for Sliver. There's a little bit of issue with how there's still some strings that are kind of residual in there, but this again this is an alpha. This is an example of an alpha C2 framework that is still very powerful. So it'd be really cool to see once this thing is built in fruition where it goes. Yeah, and all of these really, I mean, kind of lead into this idea that there's pretty much a C2 for any use case that you need. Like if you need Linux, if you need Windows, if you need Mac, if you need Mac specific, if you need Linux specific, if you need Windows specific, there is a C2 out there. So cool enough, there is also a C2 matrix, and I believe it's at the c2matrix.com is what it's called. And this lays out all the different C2s that are known publicly. This does not include, the secret FBI or NSA ones, but it includes mainly ones that are known by just like on GitHub or say, for example, Cobalt Strike that they have advertised publicly. And this is really nice because you can actually sift through all the different C2s that exist for different qualities based on maybe something that you need. So if you want something that's written in Python, you can find one written in Python, and one written in Go, one written in Go. If you need one that has encryption on a certain channel, you can get ones that have encryption. If you need one that has a nice pretty GUI because you hit the command line, there's one that has a GUI. There's multiple that have GUIs. And if there's one that doesn't fit your needs, you could always make your own. And I would highly recommend it. I would say making a command and control framework is probably the most humbling thing because it goes through a lot of concepts that are covered in, say, networking or just general like computer science methodologies that really require you to understand those idioms to be able to be successful when creating one of these systems. For example, you need to know how to do multi-threading, which is also leads into a networking problem. How do you deal with multiple connections at once on different threads? How do you deal with trying to generate payloads while also managing those connections? How do you deal, there's like, it kind of is a running list, and really building out your own will help you be better as not only a hacker, but as a programmer, and also to be able to debug problems that happen in a lot of these frameworks, which despite maybe being a little bit more built out than normal other frameworks, it can still run into bugs. So sometimes it's a matter of understanding how those systems work to be able to debug those issues. And real quick, I'm going to look over, oh, not that, this guy. So we have right here the C2 matrix that I was talking about, which allows us to look at, let's see here. So we have the information, which will tell us what the C2 name is, the version that's reviewed, and the implementation it currently has. You can also look at the code UI, which will tell us, first off, C2 name, what the language the server is in, the language that the agent is made in, which is the implant that's going to be put on the target system, if it allows for multi-user, if it has, what kind of UI it has, if it's just a command line interface, if it's in a web, maybe through like JavaScript, or if it actually has a standalone GUI that you can download. And then if there's an API. Some of these tools allow for extendability based on an API of some sort. One that I can think of, for example, is PowerShell Empire. PowerShell Empire, despite this one saying it's written in Python 2, has been recently rewritten for Python 3 and implements a really nice Rust API. And this allows you to really kind of dig into the nitty-gritty of how the C2 framework works and be able to build your own tools and scripts that may be able to automate some of these concepts in PowerShell Empire or maybe whatever framework you're using at the time, so that you don't have to worry about trying to click through or go through it manually and have to do this arduous task every single time. So it definitely helps with developing more codified workflow. I'm also going to show off too. So this is Cobalt Strike. Recently, kind of the site's been really redone, and it shows off a lot of really cool use cases for Cobalt Strike, the general purpose for it, different services that they offer. But as you can see here, the pricing for this is $3,500 per user for a 1-year license. So as a general user, probably not going to be using this because I don't have $3,500 just to, burn for no reason. So this is where we can move into something like Metasploit, where Metasploit has a really simple methodology where we can actually just go to their website and download the open source Metasploit framework. There's also a GitHub page for this too, that you can look at all the source code for this program. You can also build it from the repo as well. And they have a nice installer that you can use instead if you don't want to build it from the repo, which actually is depicted here. I believe this is the installer itself. So it goes straight to the installer page, it looks like, and tells you how to do it. So really simple to stand up, and if you have a Kali or a Parrot OS machine, it's kind of just already included. So you can, if it's not already downloaded, you can just apt-get install Metasploit framework from the Kali repos. So that's super cool. And then Sliver here. This is the complete command and control framework called Sliver, made by Bishop Fox, which is completely written in Go. It's very nicely laid out on this page. I think this is going to be one of the command and control frameworks that I go over, at least in my tutorials, because while there are a good amount of documentations for at least how to set up certain things, maybe how to cross-compile certain implants, there is definitely something to be desired for some of the documentation. It goes into very high-level depth, I should say. So this is something I want to go more into, make something that makes more sense for these for some of these command and control frameworks. Metasploit I may not go much into because that one's really well documented. It has some amazing documentations that there's actually a whole book you can download that's just literally called Metasploit Unleashed, and it tells you how to do anything and everything you would like to, from just using Metasploit to exploit someone, to actually building your own modules and scanners and idioms for Metasploit to actually implement and use to actually exploit a system. And that is amazing to be able to do. So if you haven't done that in Metasploit, I would highly recommend that. But otherwise, Rapid7 has also a really good kind of wiki here that you can kind of move through and look at the content. It, of course, goes more over the Metasploit Pro. As you can see, the graphical interface here, that's for the Metasploit Pro. But Metasploit actually has on their website a nice documentation that's kind of similar to this that you can go to. Let's see. So framework documentation. Maybe they changed it. They might have revamped it. I could have swore that they had maybe not. Dang. Okay. Oh, Metasploit Unleashed right here. So this is the offensive security Metasploit kind of like guide. It might be a little dated for some of the contents, but the Metasploit Unleashed book is based around a lot of this. It goes a little bit more in depth, of course, but this is a lot of the content that's just kind of related in that book. That actually would be nice. This is like a little cheat sheet reference for that, which is super cool. It goes into exploit development, web development. Yeah. Anyway, so there's a few different frameworks that we can go about going into, and I'm really gonna touch on probably just about 3. Like I said, I may not go into Metasploit, but we'll see. We'll see where things go. I may just bombard with a bunch of videos. So without further ado, thank you very much for watching this video. And if you have any questions, please leave them in the comments below, or feel free to message me on Discord or Twitter, whatever. I'd be more than happy to answer your questions. If there's a video request you want me to do, if you want me to do a specific video on a concept such as maybe binary exploitation, or just maybe pen testing concepts, or Windows red teaming concepts, just let me know and I will make a video on it. All right. Thank you very much. You guys have a wonderful day, and I will talk to you all later.